Subtopic 5.3 Inverse Functions. Learning outcomes. At the end of the lesson, students should be able to identify whether a function has an inverse and find the inverse of the function. Second, compute the inverse of a function. Next, find the domain and range of an inverse function. And the last but not least, students should be able to sketch the graph of the function f and its inverse, f inverse, on the same axis. Inverse functions. F is a one-to-one function. If f is a one-to-one function that maps x to y, then the inverse function, written as f inverse, f to the power of -1, is a function that maps y back to x. The domain of f inverse is the range of f. To verify that f inverse is the inverse of f, we're going to use this formula or this one. Inverse exists only for one-to-one function. If the function is not one-to-one, so the inverse does not exist. The relationship between a function and its inverse. The graph f inverse is the reflection of the graph fx about the line y equal to x, as illustrated below. Before we start, take note that only two functions that are not one-to-one, which is quadratic function, and also modulus, absolute. A, fx equal to 3x plus 6. This is a linear function. So linear function is one-to-one function. So since fx is a one-to-one function, thus f inverse exists. So since the inverse exists, we need to find the inverse function. To find the inverse function, we are going to use this formula. F inverse equals x. Which means we're going to substitute f inverse into the f. So 3 f inverse plus 6, and then make it equal to x. Rearrange until we have f inverse as a subject. Next, b, this is a quadratic function. Quadratic is not one-to-one function. Thus, f inverse does not exist. C, fx equal to sed x minus 1. This is a square root function. Square root function is a one-to-one function. Thus, f inverse exists. So if f inverse exists, we need to find the inverse function by using the formula f inverse equals x. So substitute f inverse into the f. Equals x, and then rearrange until we have f inverse as a subject. D, this is a reciprocal function. Reciprocal is a one-to-one function. f inverse exists. So find the inverse function by using this formula. Substitute f inverse into the f. Make it equal to x. Rearrange until we have f inverse as a subject. E, modulus. Absolute or modulus. We know that absolute function is not a one-to-one function. Thus, f inverse does not exist. And then this one is a cubic function. Fx is a 1. Thus, f inverse is exists. Since it is exists, so we need to find the f inverse. Substitute f inverse into the f. Then rearrange until we have f inverse as a subject. Example 23. Find the inverse for the function fx. Hence, sketch the graph and its inverse on the same axis. Determine the domain and range for the function and its inverse. First of all, we doesn't need to find the f inverse since it is the same with example 22c. Here, 22c. We already find the inverse, which is x squared plus 1. So now, we're going to sketch the graph fx. So to sketch the graph fx is a square root function. So we take the values inside the set and make it positive, greater than or equal to 0. So x greater than or equal to 1. And then I'm going to draw the y-axis and the x-axis. X equal to 1 is somewhere here. The coordinate of the starting point is 1, 0, since we doesn't have anything beside the set. So 1, 0. So here, and then it's going to be like this. Draw the reflection line, which is y equals x, and then reflect to the line to find the graph of f inverse. So since here is x equal to 1, so for the inverse is y equal to 1. Then draw it like this. This is f inverse. Next, we are going to determine the domain and range for the function. I'm going to find the domain for f, which is 1, infinity. The range of f is 0, infinity. So the range of, the domain for f inverse is equal to the range of f. So it is equal to 0, infinity. And the other one, range f inverse is equal to domain of f, which is 1, infinity. Example 24, the function f and g are defined by f equal to 2x minus 5 over x plus 3, g equals 3x plus 5 over 2 minus x. Find f gx and g fx, hence state the conclusion about the results. So to find the f gx, we just need to write down the function g, 3x plus 5 over 2 minus x, and then substitute all the thing here inside f, which is into the x. Next, simplify. Then equate denominator. Equate denominator. And then this thing can be cancelled out. So we have 11x over 11, which is x. And then we do the same thing for gfx. But for gfx, the inner function is f. So write down the function f. And then substitute f into g, which is into the x. Then simplify. Equate denominator. Equate denominator. Then these two can be cancelled out. So we have 11x over 11, which is x. So we already find the values for ftx and gfx. Next, we need to state the conclusion about the results. Since we have fgx equal to x and gfx also equal to x, thus f and g are inverse of each other. This is because we know that if we would like to find the values of f inverse, we use this formula, and then we make it equal to x. This means that f inverse is the inverse of f. 5.4. exponential and logarithmic functions, learning outcomes at the end of the lesson, students should be able to find a relationship of exponential and logarithmic functions by using algebraic and graphical approach. Next, students should be able to sketch the graph which involve exponential and logarithmic functions on the same axis. Relationship between exponential and logarithmic functions is that exponential is the inverse of log, whereas log is the inverse of exponential. The graph f inverse, which is the logarithmic function, is the reflection of the graph of f, which is the exponential function, about the line y equal to x as illustrated below. Example 25. Given that fx equal to ln for x minus 3, A. Show that fx is a one-to-one function. B. Find an expression for f inverse. C. Determine the domain and range of f and f inverse. D. Sketch the graph of f and f inverse on the same axis. So A. To show that fx is a one-to-one function, we can use the algebraic method or the graphical method. I'm going to use the algebraic method, which is let fx1 equals fx2, where x1, x2 is the domain of f, and then substitute x1 into the x, and then substitute x2 into the x, and then compare. So we have 4x1 minus 3 equals 4x2 minus 3. Rearrange, simplify. So we have x1 equal to x2. Since we can prove that x1 equals x2, so fx is a one-to-one function. For B, we need to find the inverse function. So use this formula, f inverse equals x. So substitute f inverse into the x, rearrange until we have f inverse as a subject. C, we need to find the domain and range for the function f and its inverse. Domain and range of f and its inverse. So fx equal to ln for x minus 3. So to find the domain for f, I'm going to use the algebraic method. The values here must be greater than 0. So x must be greater than 3 or 4. So the domain f is greater than 3 over 4, means it starts from 3 over 4 until infinity. Then to find the range, need to let y equals fx. Y equal to ln for x minus 3. Rearrange until we have x as a subject. Y can be all real numbers. So y subset all real numbers. So the range of f is all real numbers. So since we already know that the domain of f is also equals to range of f inverse, and the range of f is equals to domain of F inverse. So we can conclude that the domain of F is 3/4 infinity. Range of F is all real number or negative infinity infinity. Domain F inverse, which is equal to range of F, negative infinity infinity, and the range of F inverse equal to domain F, which is 3/4 infinity. And for the last one, we need to sketch the graph on the same axis. So draw the y and x axis. For the first function, fx equal to ln 4x minus 3. So the asymptote is 3/4. X equal to 3/4. And then the shape's going to look like this. For the exponential, I'm going to reflect the graph on the line y equal to x. So this one is F. So the F inverse going to look like this. And the asymptote for the F inverse is y equals 3/4. And then I'm going to label it. This one is F inverse. Composite functions involving inverse functions. Note that Fg inverse is equal to G inverse F inverse, and G F inverse is equal to F inverse G inverse. Example 26. The function f and g are defined as fx equal to sed x minus 2 and gx equal to x over x minus 2 respectively. Find the inverse function f inverse, g inverse, and fg inverse. So I'm going to find the f inverse first by using the formula. So we just need to substitute f inverse into the f. Then make it equal to x. Rearrange until we have f inverse as a subject. Then the same thing goes to G inverse. So G inverse equals x. Substitute G inverse into G. Make it equals x. And then rearrange until we have G inverse as a subject. Then we need to factor out G inverse, 1 minus x. Since we have these two here, G inverse, factor. Then G inverse equals negative 2x over 1 minus x. Or you might get 2x over x minus 1. This is the same thing. Next, we are going to find Fg inverse. I'm going to use the properties up here. Fg inverse equals G inverse F inverse. G inverse F inverse. So I just need to substitute F inverse into G inverse. F inverse is x squared plus 2. Then substitute this thing into G inverse. Then rearrange. Which is negative 2x squared minus 4 over negative x squared minus 1, or you might get 2x squared plus 4 over x squared plus 1.